Good morning, good afternoon, and good evening, and welcome to Energy Speaks Back, powered by B2B Energy. My name is Paul Webb, and I'm the founder of B2B Energy, and I'm your host. Weekly, I present to you energy experts from around the world. Welcome to episode 146. Our purpose, as always, is to provide a good understanding of energy management knowledge from around the world, which is available today for us to deliver savings that impact on our planet. Welcome, energy enthusiasts, to another enlightening episode of Energy Speaks Back. Today's guest is a BMS expert in energy and sustainability. He installs, supports, and guides the installation of building management systems. But more importantly, he has become a BMS trainer for the industry. So without any further ado, let's dive into the conversation with Ian Ross. Good afternoon, Ian. How are you today?
Very well, Paul. Very well. Thank you for inviting me onto the podcast.
And brilliant. And this is the first time we've done an interview in a Tesla. So we're using a Tesla as a studio today.
We're all about technology and about being efficient. And I can't think of anything more efficient than using dead time whilst you're in the car to improve the energy industry.
Exactly. And, you know, we're grabbing a time when we can on for Zoom calls. And I know we've been doing the training with you. We've occasionally we're sitting on a charger or we're in a lay-by somewhere, obviously, not while we're driving.
Not whilst you're driving.
Using the full technology to where we to the maximum benefit, as always.
Well, exactly right. I can remember the first time, and it was whilst we were doing the 11-week program, that you suddenly noticed that there was an armrest behind me, and you wondered what it was. And that's when I broke the disturbing news to you that I wasn't sat in front of a PC. I was actually sat in my car, charging up whilst we were talking. So I was using that dead time that modern vehicles give us now, the EV vehicles, of course, when we are recharging them. And we can now really turn that into productive time if we're intelligent about it.
Yeah. And I always know you're in your Tesla because the camera gives your shirt and everything around it a slight purple tint, doesn't it?
It does. It's we'll have
From
to have
window.
a chat with Elon about that. Get a higher quality camera inside the car. You know, if he wants Teslas to stand about, he's got to keep moving forward with technology.
Brilliant. And where you based at the moment, Ian? Where are you sitting currently?
Yeah, so I'm in Basingstoke, sunny Basingstoke. Well, not so sunny today, actually. I could look through my glass sunroof at the lack of sunshine we're having at the moment. So Basingstoke, the English Riviera, as I like to call it. I've been out to see a customer today, looking after their facilities from a BMS perspective, as you know, I'm being a BMS engineer, and talking to them very much about energy efficiency. And it's quite interesting that there's still that sharp intake of breath when you start talking to them about approaching their building facilities in a different way for energy efficiency, because the first thing they start clamoring about is comfort, as if the whole energy industry is not concerned with people's comfort at all. It's very bizarre.
Well, let's come back to that. Let's take a couple of steps back. So we've been doing the training, and you contacted me around about last year, and we've gone on the 4 principles, 11-week energy program, the technology. We've finished through that. We're now on the lifelong learning. You're a very big participant within our networking group, which is great because you bring in the BMS element of it. So for the benefit of the audience, obviously I know a lot about you. So for the benefit of our audience today, can you tell us about your background story and your origin story? You know, what made you get into this industry?
Yeah, well, I served, left school at 16, when you were allowed to leave school at 16. Started an apprenticeship in a paper mill. The paper mill was only recently shut down, actually stopped trading in the UK. It used to make banknote paper, security paper, as they used to call it. Right. So it's a specialist industry. And I did a traditional apprenticeship with them, 4-year apprenticeship, an electrical apprenticeship. But we were fortunate enough to touch upon virtually every aspect of the engineering function that went on within the mill. So I did a lot of normal engineering type things, but I also got involved in process control. So I was involved in automation right from the beginning of my working career. At the end of my apprenticeship, I left the mill after getting a couple of years' experience after the apprenticeship. Went into building services, maintenance, and I really got interested in refrigeration. So I learned a lot about refrigeration, big chiller machines in plant rooms. And I also noticed, as well as having these huge chillers in plant rooms, you had these control panels as well, MCCs as we used to call them, motor control centers. And on the end of them, there was a control section. And I was noticing more and more these boxes appearing, black boxes, orange boxes, with lots of wires coming in and out of them, and seeming to magically make all this stuff operate.
Right.
And so, started asking people about it. They told me, oh, that's the BMS. It meant nothing to me at the time, automatic controls. If they'd have said that's the automatic controls to what I knew from the mill, but they just called it BMS. So I started investigating that. Right. Okay, Paul. So I'm on my drive now. I don't want there to be a clash of technologies between Tesla and my Wi-Fi. So let me go and set up upstairs in my office at home, and we'll rejoin the call, and I'll continue on with my potted history.
Brilliant. Look forward to it.
Okay. See you shortly, Paul.
Hi, Paul.
Hello. There he is.
We're back. We're back.
We're back in the room. It looks like you've changed your top as well.
Oh, I've got black top on now. Brilliant stuff. Brilliant stuff.
Okay,
Yeah,
so
the old glass. Got a lot of reflection there.
Let's talk about let's continue your story. So we're in the paper mill. You've just identified and realized what a building management system is, BMS.
Yeah. So a little bit of introduction, and I'm one of these a typical engineer. When my curiosity's peaked, I have to go and satisfy it myself. So I learned a lot about various control systems, and this was in the days really when it was just the major manufacturers that you were talking about. So I've come across a lot of Honeywell, a lot of Stafer, as it was at the time, a bit of Siemens. And this was really in the days trend were really first starting. Right. So it's become a bit of a player in the market.
We're talking the 80s now.
Late 80s, early 90s, yeah. So and I just became fascinated by it. And I was lucky enough to start looking after a customer, digital, the digital corporation. I don't even know if they exist anymore, to be perfectly honest. And they had a tie-up globally with a company called Tor Anderson, and Anderson, that became TAC.
Yeah.
They're now part of the Schneider Group.
Yeah.
And they had these mini computers that were put away in a plant room office that was the BMS head end, all Unix based. You had to be a bit of a computer nerd to really understand them. And that really piqued my interest. And I started learning a lot about BMS head ends and automatic control in the HVAC industry. And then slowly, I'd start meeting controls engineers that would turn up. And there was me, humble maintenance guy, driving about my little van, quite happy with my overalls on and all that, just doing normal maintenance type jobs. And then these guys would turn up, the controls engineer, the BMS engineer, and they would be really smart. They'd be there. Some of them would turn up with shirt and tie on, but they would definitely be very smart. They didn't look like me. And they'd have nice, neat tool bags. Some of them had, computers that they carried around with them. They were getting mobile phones. They had really nice cars. And I'm thinking, God, these people, and they were up there. They were up on a pedestal. I thought, these people must be sort of super geniuses. And so I started to try and learn as much. Every time I got together with these guys, I'd be sort of absorbing by osmosis their knowledge and really beginning to understand, well, I know a lot of this, but I can relate it to a process rather than HVAC. Yeah. And I thought, you know what? There's not so much mystique about it, but I'm really interested in what they do. And I saw a job advert because a BMS manufacturer had relocated from Slough to Basingstoke. And it was in my local paper, and it was an advertisement for a trainee commissioning engineer. Would suit an electrician looking to further their career. I thought, that's me. I'm an electrician looking to further my career. Yeah. So I went for the interview. I got the job, and really from day one, I thought, this is it. I love it. And 30 years later, I'm still in BMS and still love it. Well, I love it more each day. It's a great industry to be in.
Yeah. What was the manufacturer you joined?
The manufacturer I joined is a Swiss manufacturer called Sauter. It was
Right.
Sauter Automation in the UK. They still exist, still in the same offices in Basingstoke. A lot of the guys that I got to know when I first joined still work there. It's a real, it's a great company. You know, I really do take my house, and I'm very,
Yeah.
very thankful that I'm in the position that I'm in today purely because some really gifted and generous people at Sauter took time out to invest in me, and that's led me into a lot of what I do as well today, trying to further our industry and develop people's knowledge, attitudes, and skills in our industry as well. So yeah, it was a really good introduction to the BMS world.
So the BMS you learned, was that closed protocol in them days?
Yeah. Sauter. Well, everybody used to have the closed protocol. Everybody was proprietary, and there's great benefits to proprietary networks. You know, I know it's got a bit of a bad reputation, but there's a lot of benefits with proprietary networks. Obviously, the negative is you're a little bit more tied in than if you go for an open protocol. But yeah, so Sauter was a closed protocol. So we never really used to think about networking and communications and everything because one of the benefits of closed protocols is they very much just look after themselves. So I was able to focus on the automation side of things,
Mm.
actually getting stuff working, actually, following a specification and a description of operation and making sure that the building ended up delivering what was in the written word. But of course, now we've expanded that out now, and we're a much more inclusive, much more open industry. And what that's meant is that the standard commissioning engineer's skill set is a lot wider than it used to be.
Yeah.
And it touches on so many different industries that BMS people really are becoming the hub in the wheel of the energy industry now. And it's something that I know you and I have spoken about a lot. And I think we're still on those early days of making sure that we turn away from the old let's all compete and fight with each other to let's start cooperating with each
Yeah.
other a little bit more.
Collaboration.
Exactly right. Yeah.
So your training was around a closed protocol. What are you agnostic now? Do you align yourself to any particular BMS systems, or you can you
Um,
cover pretty much all of them
I
now?
think it's impossible to have a sufficient working knowledge in all the systems that are out there. So
Yeah.
you have to realize that your knowledge is going to be limited by what you choose to learn. There are systems that are probably more beneficial for you to get involved in than others, just because they're more widely adopted. Obviously, within the UK, the big player has been for decades Trend. And Trend are part of a huge corporation now, the Honeywell Corporation, that include other BMS brands as well. One of them being Tridium, other
Hmm.
one being Allerton, which is big in America. But Tritium really is quite an interesting proposition, and I'm finding a lot of the BMS world is gravitating towards the Tritium product with their Niagara framework. And that gives that's great in a multitude of different ways. One, interoperability, and two, you can learn your Tritium skill set and then apply it to a whole host of different manufacturers' products.
Yeah.
So I think that's really quite useful.
You alluded to the beginning that you've gone in to see a client today, and
Yeah.
we've still got this nervousness, and there's still this element of training that still needs to get down to that
Mm.
level, isn't there? And
Oh,
understanding.
definitely. I know BMS particularly has always been considered a bit of a dark art
Yeah.
within the HVAC world. And for good reason as well. For a long time, we did play our cards very, very closely to our chests. And we took on the attitude of that is my customer.
Hmm.
They are my customer. Nobody else must talk to that customer. That customer must only have trust in me. And that's a different world, a different
Yeah.
world. That's an ancient world now. And we're now in an ultra competitive world. And there are so many different technologies that our customers need to know about that we can't afford for them to feel that we're not playing our part. So I approach things very much, you use the word agnostic. I approach everything now really from a systems agnostic position because without wishing to insult anybody within my industry, a BMS is a BMS. It really is. There's only four types of points on a BMS. There are two types of inputs and two types of outputs. So
Mm.
you have an analog input or a digital input,
Yeah.
and an analog output or a digital output. All BMSs have those. Okay. So they are completely the same, whether you're picking a green box, an orange box, or a red box. They've all got the four types of inputs and outputs. Then it's the language that links those inputs to those outputs. And virtually all BMS manufacturers now have decided to use a programming language that is called a function block language. So
Hmm.
rather than lines of code and you needing to be a computer program, you pick a block with a specific function. Now that function could be logic, an and, an or, a not gate, or something like that. It could be a module that allows you to create an input, a module that allows you to create an output,
Yeah.
or something like a PID loop. And then they're all very similar across all the manufacturers.
Yeah.
And the great thing is, as a BMS engineer, the learning curve is quite shallow from one system to another. So it's quite easy to be an expert in one system, but not just be limited to that system. It's very, very easy if you apply yourself and you get good teachers, obviously, to take the knowledge you've already got and just basically change the accent a little,
Yeah.
and you go from one manufacturer to another, and very quickly you're comfortable with this new product,
So
which is great for customers because
and
they're not locked in.
simplistically, it's like having an Apple laptop and a Microsoft laptop, isn't it? At the end of the
Yeah,
day,
yeah, really are. But
and
I would
understanding
say
how your
BMSs
way
are
around
even
it.
close. Yeah, BMSs are even closer together than the differences between Apple and Microsoft.
Yeah.
It's almost a case of almost you could say it's like the difference between Windows 10 and Windows 11.
Yeah.
Almost. That's
Yeah.
how
No,
close
I get what you're
they
saying.
are.
Yeah.
Yeah.
I
So
mean, you just upgraded something. Yeah.
exactly right. Exactly right. So, but we've got to get to that point where we are more open with the industry, where we're prepared to share our knowledge and teach people and instruct people and realize that we're moving away from this competitive world into this collaborative world. And the only way we're going to get there is if we all drop our guards a little bit
Yeah.
and are more open and cooperate a little bit better.
Where do you think our challenges are there, though, when you've got different systems and different individuals trying to, you know, not necessarily
Um,
collaborate as such with they're competing in the world, aren't they?
Yeah, it's a multi-pronged issue, and I look at it very much from a technical point of view. I'm an engineer, so I'm always going to look at things from a technical perspective.
Hmm.
I've got a commercial head, I was very involved in commercial activities in the past. Sales was never my thing. I do believe that the traditional sales model that we see in HVAC, where somebody has an account or a region with a target, is very, very restrictive in what we're trying to move towards.
Hmm.
And I've had this discussion many, many times across many different organizations that one of the worst things we seem to do with sales guys is from day one, we give them a sales target. So all they're interested in doing is hitting a number
Yeah.
rather than the quality or the type of work they're bringing in. And
Mm.
I don't blame them because a sales guy gets measured by what he sells.
Yeah.
And the easiest measure of that is volume. But unfortunately, we get ourselves into a situation where maybe a sales guy will take the safe option
Yeah.
or the shorter term option to get the results in to secure his future and then secure his well-being. And I'm not blaming anybody from that. That's just from an engineer's perspective. I can see that perhaps as an issue. Maybe from a sales perspective, they see my need for perfectionism being the problem. I want a system to be perfect rather than better than it was yesterday.
Mm. You're working in an environment now, don't you? Because you do training yourself. You're training
Yeah.
individuals in the controls sector, aren't you?
Yeah, I've evolved into that. I've always really enjoyed learning. I've always really enjoyed then passing on that knowledge to other people. And I've always tried wherever I've worked to help develop people. Or if I'm working with somebody and I know something they haven't picked up yet, I've always got a bit of a buzz out of passing that knowledge on to people.
Yeah.
Inherently, I always make a joke of it, say inherently I'm lazy. I want to teach my way out of work.
Yeah,
You
yeah,
know,
yeah.
and it's addressing a big issue that we've got in the industry at the moment because it's a growing industry. Uh, Everybody's heard of energy efficiency, net zero, carbon, all these things that we talk about every day. And really, within the HVAC world, BMS plays a pivotal role in this. And there just aren't enough good engineers in the marketplace. Um, and what's happened is we've got lots and lots of work, and there's very, very few companies out there that have got empty order books anymore. To the point where I know lots of organizations that are regularly having to turn work down because they don't want to overstretch themselves. They
Right.
want to keep the quality of their delivery high, and realize that, yeah, they've got their quantity of engineers. And to get more engineers, it's either going to be very, very expensive to get the quality of engineer they need, or it's going to take time to train somebody up to that level.
Mm.
So it's better. We're almost getting to the point now where we're going to have people taking engineers on and then going out and finding the work. And the old commercial model was we'll find the work, then we'll worry about resourcing it.
Yeah.
We can't afford to do that anymore. So, yeah, so I've always had this thirst for knowledge, this bent to pass that knowledge on. And recently that's been more formalized now through Sonsei, if you don't mind me mentioning Sonsei, and their academy, the Building Controls Industry Association, and Group Horizon, who are a training organisation. I've been very, very fortunate to get involved in delivering the BCIA training through the Sonsei Academy and through Group Horizon to apprentices and mature engineers in the industry.
Right.
And there's a series of modules that have been more formalised and looked after by the BCIA now, so that we can take engineers through a proper learning journey to make sure that they are adequately equipped with the knowledge and the access to the principles that make for good BMS.
Yeah.
And one thing that I always try to do is I always give people my contact details. Whoever is on the training course, always put my contact details up and say, look, take them if you want them. There may come a time when you're stuck and you've got nobody else to turn to. Give me a call, drop me an email.
Yeah. Yeah.
I won't guarantee to have the answer, but you won't be on your own. And I'll say, at the very least, if you're struggling, ring me up and you've got somebody to talk the situation through. And you'll probably find that by talking it through, you'll suddenly discover a solution yourself. Because
So,
I love the old, I think it might be Plato or Aristotle, who turned around and said, I can't teach a man anything. I can only help him to find it within himself. And that's very much the way I approach it. You know this, I know you know it. I just need to remind you of it. I need to help you to remember it.
yeah.
And
I'm going to
yeah,
know
so
that.
that's very much my approach.
This training, is that product related, or
No,
again, is
no,
it the strategy
it's
of building management?
yeah, we do touch upon some product, but it's not system specific. So it could be from any brand of BMS. Okay,
Yeah.
so whether you're a Trend engineer, a Schneider engineer, a Honeywell engineer, it doesn't matter. You can come along and do this training because it really is foundational.
Yeah. Yeah.
It's to do with basic principles. Because if you think about it, automatic controls, automation has been about probably for about 150 years. Yeah, we've certainly had some form of automation since the Industrial Revolution. The first devices really that we talk about, and there's a big argument which came first, and the real first automation equipment was the time switch and the thermostat. And all BMS is built upon time schedules and temperature control,
Right.
or some form of automation, measurement and set point and adjustment. So from that, the foundations of BMS around measuring something, comparing it to a desired value, making adjustments based on that error, it still exists. That hasn't changed. Switching stuff on, switching stuff off hasn't changed. We've just got a little bit more sophisticated in how we do it. And we maybe can put a pretty picture with it, and we can export some data, and we can analyze and turn that data into information, which we weren't able to do 50, 100 years ago, or not as easily, should I say.
Mm.
So what we tend to focus on is not a specific product training. We'll let the manufacturers do that because they do it really well. They know their products inside out. Let them deal with the specifics of their product. What we can teach engineers is the philosophies and the thought processes behind how do systems work.
Yeah.
And this is what I say to people, that to be a good BMS engineer, it's not about, oh, this lead plugs into that port and I talk this protocol. No, it's about, have I got a system? Have I got some plant? How is it meant to work? How do I make it work well?
Mm.
Okay, then I can relate that to the product I'm using to control it. And I can turn that into an algorithm and a strategy within my BMS to actually make that plant do what I want it to do.
Yeah.
So steering away from a specific product is probably more beneficial.
Yeah, totally agree. In my days, we all know that I'm ex-BMS, worked for Trend for 10 years. In my days, we become the keyboard warrior in a way, because we were stuck there with the product, because we knew the product inside out and all the problems were around the product. As soon as we stepped out of the plant side, the valve, the pumps, it started to go very grey.
Yeah.
No, we was orange totally, and then it went grey. We struggled with it, and we had to. It wasn't, and this is when the building energy management system, which is what it started out to be, fell into being a BMS system, purely building management system. And then in the mid-90s, this is where we then started, trying to develop, bringing the E back into energy, the BEMS. We started calling it, we don't call it BEMS anymore. And I don't think that's like a fashion thing, but we called it the building energy management system. And that's what it was. And that's what it is. Now we know by putting a building management system in, see, I've fallen back into it straight away, that we're going to be making at least a 35% energy saving on that building. If we train people, if we educate the customer, and also if we maintain it, of course.
And it's all about sharing knowledge, Paul.
Yeah.
It's all about sharing knowledge, and it doesn't stop. It's not just commercial buildings, it's all types of buildings, because the principles, the philosophies, the foundational work is the same, whether you're dealing with a studio flat or whether you're dealing with a 50-story commercial office block.
Yeah.
Because, the scale is vastly different, but you're still dealing with a system. And systems have inputs and outputs. Systems have losses and influences, and that every system has those. And I think if you can understand systems, particularly in our industry, plant as well, then you've got the opportunity of being a good BMS engineer, being a good energy engineer. Full stop.
Yeah.
And maybe the breakthrough for us will be stop calling ourselves BMS engineers and start calling ourselves energy engineers, because we do influence what energy is used, when it's used, how it's used.
Yeah.
And that is the key to actually having an efficient world.
I don't want to put you on the spot too much, but do we know roughly how many buildings, what's the percentage of new builds going to have a BMS system in nowadays?
Well, fortunately, our favourite bedtime reading, the building regulations, Part L, that dictates now that all buildings must have a minimum of BMS.
Yeah.
Okay. So all new builds, particularly buildings that are going to be rented out, so in the commercial rental sector, they have to be a Class C building, which has a basic level of automation. So that'll be zone control, time scheduling, weather compensation. So it'll have a degree of energy efficiency built into it.
Yeah.
Now, that doesn't necessarily mean that it will be an all singing, all dancing BMS system. No. It may be very basic. You might have one control panel. You might have a touch screen display somewhere that gives you some basic information and some graphics. But the beauty is now with virtually all modern BMS systems is they are all scalable. So you might start with your basic BMS to be a Class C building, and within your corporate KPIs, your corporate strategy is to be an excellent organisation. So you'll be looking towards BREEAM excellence. You'll be looking towards some sort of excellent net zero strategy, and you'll be looking to move your buildings from that Class C up towards a Class A building.
Yeah.
Well, the beauty is you don't have to throw the baby out with the bathwater. The BMS you start with is your cornerstone.
Yeah, yeah.
And if you look in architectural worlds, you always start a building off with a cornerstone. Well, that first control panel, that first controller, that one touchscreen is your cornerstone, your foundation, and you just build upon it.
Yeah.
But the real importance is, and this is something that I think we can't stress enough, is it needs to be part of a strategy. And you won't get a really good strategy if all you're trying to do is chase price. And we have a horrible habit in this country, and particularly in our industry, for being a race to the bottom on price.
Yeah.
And we only ever measure what people do by how low their price is. And I think particularly for commercial landlords, property owners, or people who have an interest in energy efficiency, a quality strategy is the most important thing in exclusion to everything else. And I think if you get that strategy right and you partner with people to develop and deliver that strategy, you'll get much more satisfying results.
Yeah. I remember working for Trend in the city, and we'd often go in, and the amount of stuff that was engineered out of the system because it was down to cost. All the energy management, all the compensation, all the switching boilers, staggering the boilers to outside air temperatures, free cooling, all those sort of things were all managed out and engineered out to bring the cost down.
Exactly. The
Crazy
infamous
times.
value engineering.
Yeah.
The infamous value engineering. Yeah. And we've got horror stories. We can terrify people with the horror stories. But I think one of the worst situations I saw was a school. And it was a brand new school. It was only a couple of years old, gone in because terrible temperature control. Everybody was uncomfortable. They put an underfloor heating system in. Underfloor heating systems work really well in schools if they're designed and controlled properly. But part of the value engineering exercise was actually to take out a lot of the temperature monitoring in the classrooms. So they had these wonderful underfloor heating systems, which are great, but no reference data for each classroom to actually say how hot or cold the room was.
Yeah.
So effectively, they were then grouping classrooms together on one temperature sensor.
Yeah.
So
which is probably
it just didn't work.
in the main reception area.
Yeah, exactly right. And something else as well, particularly when you look at, lots of organization, one thing that gets restricted a lot and gets squeezed every year is their operational expenditure, their OPEX.
Yeah.
And if the data that's being collected within your facility is poor, you cannot control your OPEX because you don't know where you're using your energy.
Mm.
And that's what we always say, that's the third biggest expense in all organizations is the energy. And if you don't know where it's going, how can you control it? We know my mantra, Paul. If you can't measure it, you can't control it.
Exactly.
Yeah. So
we have the same hymn sheet that we sing.
We do. We just got to make sure that everybody catches on to the tune, don't we?
So where we are now, what's your thoughts on the actual maintenance and support of building management systems?
Well, that's a double-edged sword because one of the great things about technological advancement and development is that the actual maintenance, the reliability of equipment has grown exponentially. Well, actually, we have engineered obsolescence now. Products are actually designed to fail after a period of time because the quality is so high. So the old school maintenance of somebody going around with some screwdrivers and spanners and adjusting things, a lot of that's gone now. And for me, the real maintenance activities that we need to be doing is looking at the performance. So it's around, I break my energy philosophy down into 3 steps, which is effective, efficient, and optimized.
Yeah.
We've pretty much dealt with the effectiveness now of equipment. It's good quality now. There's very few manufacturers out there that don't make a quality product anymore.
Mm-hmm.
So the reliability, the accuracy is all there from day one, and it lasts a long time. I can remember when I first started at Sauter, if we'd mentioned the word thermistor when regards to temperature measuring, you were likely to get a slap because thermistors 30 years ago were rubbish.
Yeah.
They were very inaccurate. They would drift. They were awful. Whereas now you look at a thermistor now, very, very good piece of equipment and still incredibly cheap. compared to other
price.
types of sensor devices.
Yeah.
So that quality has grown exponentially. The reliability has grown exponentially. The cost of manufacturing has plummeted. And you get to a point now where I know we criticize the throwaway society, but skilled labor now is so expensive compared to the price of product that we don't need to maintain things anymore because it's too expensive to maintain them. So we take them out, replace them with new. And that goes alongside with, say, you look at a valve, for example. We still have valves, and at one time I can guarantee that you'd have to change the seals and the packing in a valve every couple of years. You'd regularly be adjusting the valves so they wouldn't leak. You don't anymore.
No.
They'll last for 20, 30 years until they seize up, corrode, or start leaking. Then you just replace them. And you think, well, that goes from something that probably would have needed 10 or 15 maintenance interventions throughout its life to something that will need only one maintenance intervention through the same life. So that traditional maintenance has gone away. And what we tend to do now is a lot more verification within our maintenance. So we'll want to know that our sensors are still reading accurately, that the conditions that they're operating in haven't changed so that they're not outside their tolerances. The use of the building, how has that changed over time? And then take plant through a functional test. Do you get the right lift across AHU coils now? If you've got a frost coil and its lift is 6 degrees, right, we'll measure it. Am I getting 6 degrees lift across that frost coil when I operate it? So it's more about, is it performing to how I want it to perform rather than is it actually doing anything anymore?
Yeah.
So maintenance now is more about assurance of delivering performance rather than it is making sure that stuff is actually working.
And valves and things like that have become more intelligent, so they get more feedback off of them now. So we know what position they're in, how to control it, etc. And you can control them more accurately. I remember we used to have certain valves, like a Belimo damper. You used to set it, and it used to go to 50%, and then carry on running for another 10%, and then before you knew it, open would be closed and so on. So it used to sort of have overrun, didn't it?
Yeah, well, that's right. You look, the electronics are so much better. Our understanding of what we're trying to achieve is so much better. And then you move into smart technology, and you're not dealing so much with electrical signals anymore. You're dealing with data, and data is exact. And what we need to realize is that what we need to look at is quality of data. Because you live or die by the quality of your data now.
Yeah.
And we're not worried about, have we got an analog signal coming out this valve anymore? The valve will talk to you, or rather say the actuator will talk to you. Very rarely now do you find a single temperature sensor. It will be a smart sensor that will give you a digital display to tell you what's going on. It'll have a set point adjustment on it. It might be measuring CO2 and humidity as well. And that's now a 2 or a 4 wire device. Whereas in the past, that would have been a multi-cord cable plus multiple inputs into the BMS. And we've gone from something that might have equated to several £1,000s worth of installation to something that's a few £100s worth of installation. But the data is massively improved.
Have you got any thoughts about what's next for the BMS? We've talked about, where we were and what we've got now. Is there any more growth and any more changes we're likely to see in the BMS world?
Yeah, definitely. Again, it won't just be in one area. AI is going to play its part.
I knew you was going to say that.
Yeah, AI is going to play its part. It's not going to take over. Luckily, I think the great thing about one of the good things about getting old. There's not many good things about getting old, but one of the good things about getting old is more and more often you say to yourself, "I've seen this before."
Right.
So I've been through 2 or 3 iterations now where this wonderful new USP or this new technology is going to replace the commissioning engineer, going to replace the BMS engineer. And do you know what? Yes, they bring something to the table, but they're never going to replace the human element.
Yeah.
And AI, I think, will give us a better way of looking at our data. And it gets into things like predictive maintenance. So we can really get into condition-based monitoring. We can really get into looking at performance monitoring. And rather than us having to sit in front of the BMS 24/7 watching a graph change, we can set a little AI rule on multiple different aspects of our system that will spit out information to us.
Yeah.
And then we can act on that information.
Yeah.
And I think that's going to be one of the next big leaps forward and we're seeing a lot of it now with analytics, but analytics really is still heavily human dependent.
Yeah.
Takes a human to think of, oh, if I looked at this in this way and took that bit of information out and added it to that, what would it give me?
Mm.
And that is, we're moving into the realms of geniuses. What we want is AI tools that we can maybe interact with.
Yeah.
We can, like a scene from Star Trek, we can talk to the AI and say, I want to know X, Y, and Z about the system. And then the AI will go off and do it for us. But it still requires us to direct the AI.
Yeah, we still have to sign it off as such to say, yes, that's exactly what, because AI is great, but it still needs to understand what that BMS is trying to, what that building looks like. It may not know what the building looks like as such.
Well, that's the thing to remember, because the AI doesn't exist in the real world. No matter how good our modeling is, a model isn't the real world. We've seen this over the past years with all different types of modeling that goes on. We're talking about the weather, when we're talking about illnesses, talking about all sorts of things.
Yeah.
Modeling is very, very good. The one thing it isn't very good at is predicting the future. We're seeing that. Models give us very good answers to what's happened in the past and can give us an idea of what might happen in the future.
Yeah.
But it can never predict accurately 100% what's going to happen in the future. And that human element will then help AI to differentiate between what is good information and what is bad information. And it will get better.
Are the manufacturers working on AI currently? You get signs of that?
Yeah, I deal a lot with Tritium. And I know that Tritium have brought out a lot of machine learning, AI. It's very, very similar within our industry. I know they're different technologies, and I'm not saying they're the same, but we're terrible in our industry for interchanging phrases, giving them multiple meanings. So we're trying to bring more machine intelligence, is probably the easiest way to describe it, into what we do. So that systems can almost become self-learning. So that's what I really see as happening. Somebody might come along one day with a revolutionary sensor. The chances of that happening now quite remote, because I think we've got pretty good on sensing technology. Field devices, we're pretty much sorted.
We haven't got nothing else we've got to measure. There's nothing else that is out there that we need to measure that we can't measure.
No, and you might come up with a slightly different approach to how you look at how you use your energy, but it's going to be evolutionary rather than revolutionary. The revolution is going to be what we do with data. And from your experience in the BEMS world, Paul, we've been collecting data on buildings ever since we've had PCs connected to building management systems. It's only now that people have said, oh, we need to start collecting data on buildings. And we're sort of sitting in the corner saying, well, we've been doing this for 30 years.
We've got that.
Data?
What do you want? Yeah.
So understanding what good data is and how to use it, that's going to be a real step change for us.
Well, it's been really interesting, this, because we've gone on your journey, and your journey has followed all the different changes and the involvement within the BMS. What I'd like to do, I know you've been on the spot here regarding what we've been discussing, but is there anything that you feel that in your experience to give back to the industry as a takeaway for anyone listening to this, whether they're it'd be nice to see if we could split the answer up. If you're already in the BMS world, this is what you should be doing. But if you're not in the BMS world, this is what you maybe should be doing.
Yeah. For people that are already in BMS, if you've been in BMS for a long time and you know what you're doing, maybe consider passing those skills and knowledge on. Yeah. Bring the next generation along. If you're in the industry and you're still in that learning phase, get really good at understanding the foundations. And those foundations are systems and plant. Forget the laptop, forget the graphics, forget the amazing wizardry that we can do with IT. That's 5% of what we do. 95% of what we do is physical plant and systems. Get really good at understanding that. For anybody that isn't in the industry and is maybe looking for a career change, jump on the apprenticeship scheme. It's not just for school leavers. It's not just for college leavers. I've got members within the cohorts that I tutor that are not as old as me, but certainly are not spring chickens. So it's an industry that whatever your background is, there is an opening for you. Whatever you want to get from the industry, there's an opening for you. I was chatting to one of the guys. He was only been on the apprenticeship scheme for 2 months. He's got no engineering background whatsoever. He actually came from retail. He was a shop manager.
Wow.
But he got really interested in energy and how things were switched on and off and temperature control and stuff like that. And he was given the opportunity to join a BMS company as a trainee, as an apprentice. And he's loving it. So it's a fantastic, I love it. It's a fantastic industry. I'd recommend it to anybody. The future is bright. It's really, really bright for the BMS industry. And I would certainly recommend this industry to anyone. I really would. Male, female, any ethnic background, any creed, any preferences, there'll be a place for you in the BMS world.
So, and everyone knows, obviously, you're active on LinkedIn. What is there? Do you have a website? Do you have obviously an email that you can share with us today?
Yeah, I run my own business. It's M3 Automation. There's a story behind that. One, I'm a BMW fanatic. So my favourite car is the BMW M3. I also live in Hampshire, between junction 6 and 7 of the M3. So
Right.
so it just seemed to lend itself. So m3automation.co.uk is my website. I can be contacted on Ian Ross at m3automation.co.uk. Please reach out if there's any questions you've got, anything you want to discuss, or if you want to find out about training and development or ways into the industry. I'm more than happy to discuss any requirements whatsoever.
And obviously, you're joining us more and more regarding your training. You're training the energy experts. So, if you're an energy expert out there, want to learn more about energy management and what we're doing, obviously, you're going to be part of that team to help evolve the learning, because I think it's very important that energy
It is.
experts need to understand what building management can
It is.
provide
We've
us.
got a great group at the moment, Paul, and I hope to be able to develop a syllabus that we can deliver to that people who choose to join our little cohort of energy experts.
Fantastic. Ian, I'd like to say it's a shame we couldn't get the whole journey of the conversation in the Tesla, but obviously we would have been draining your battery and you wouldn't been able to do your journey tomorrow.
No.
And there was a bit of a fight in between the two Wi-Fi's.
There is. We're in that technological nexus at the moment. They're fighting technologies. Maybe after the podcast, Paul, you can ring Elon up and tell him to get it sorted out.
I'm going to be having words with him later. Don't worry. And we are going to do. We've promised ourselves that we're going to do some. We are going to get into the Tesla as both be in the Tesla at the same time.
I think that'd be a great idea.
And we were joking about doing it on our bikes as well, because we're both into our push bike
net zero podcast.
Yeah, that's our plan, isn't it? That's what we want to do.
That'll do. There's and again, I think we both agreed that we're caught in a massive time of change, and I honestly believe in the future children will be taught in history what we're going through at the moment. I think we're at a pivotal time in human history. And I think what will come out of this, because we really don't know what direction we're heading in, but I think the future is going to be a hybrid future. It's not going to be a one-size-fits-all future.
No.
So don't think you've got to put all your eggs into one basket. You haven't. Try to understand what's out there and make the appropriate choices for your situation.
Yeah.
That's really my takeaway when I talk to people at the moment.
Brilliant. Well, Ian, thank you very much. It's been a real honor to have you on our podcast. We keep saying we was going to do it.
We did.
I would like to say, lastly, you and your family, please stay safe in these times.
Thank you, Paul. See you again soon.